In this video, we are going to see how to construct the analytic function. Before that, let me give the introduction about harmonic function. The real function u of x comma y is said to be harmonic or potential function. Harmonic, it should satisfy two conditions. It should satisfy first condition, continuous second order partial derivatives exist. That is dou squared u by dou x square, dou square u by dou y square, u double x, u double y exist. Second one, the derivatives should satisfy Laplace equation. Dou squared u by dou x square, dou squared u by dou y square equals 0. That is u double x plus u double y equals 0. Similarly for v also, we can conclude that if v of x comma y satisfies the Laplace equation v double x plus v double y equals 0, dou squared v by dou x square, dou squared v by dou y square equals 0, then v is harmonic. Conjugate harmonic function. Next one is conjugate harmonic function. If u and v are harmonic functions, such that u plus iv is analytic, then each is called conjugate harmonic. Each is called the conjugate harmonic function. Conjugate harmonic function of other. So v is a conjugate of u is a conjugate of v. Next one is construction of analytic function by Milne-Thomson method. Construction of analytic function by the method Milne-Thomson method. So for constructing analytic function f of z, construction of analytic function f of z, you need real part, either real part or imaginary part. So first type 1, when u is given, u, that is real part, u is given, the condition is integral f dash of z dz equals phi 1 of z comma 0 dz minus I phi 2 of z comma 0 dz. Here, what is the value of phi 1? In this, that is in already we are given u, real part. You should differentiate your u with respect to x and substitute the point z and 0, which is the value of phi 1. Similarly, differentiate your u with respect to y and substitute the points z and 0. That is our phi 2 value. And another type, what happen if real imaginary part is given? When v is given, imaginary part, f dash of z dz equals phi 1 of z comma 0 dz plus phi 2 of z comma 0 dz. But phi 1 is in type 1, when real part is given, you should differentiate with respect to x first and then differentiate with respect to y. Whereas when imaginary part is given, phi 1 value is differentiate your v with respect to y. Initially you should differentiate your v with respect to y and substitute the point z and 0. Phi 2 is differentiation of v with respect to x at the point z comma 0. This is the process of construction method of analytic function when real part and imaginary parts are given. Question number 1. Show that, most important question, show that the function u equals half log of x square plus y square is harmonic and determine its conjugate. Determine its conjugate, that is we should find v because in this question u is given. Also find f of z. Also find f of z. So first we will check whether u is harmonic or not. So to prove u is harmonic, u equals half log of x square plus y square. First differentiate with respect to x. Half log differentiation is 1 by x square plus y square, and then x square plus y square should be differentiated function of function rule. When you are differentiating with respect to x square is 2x, y is constant, so it will become 0. Now these two terms get cancelled. Ux value is x square plus y square. Next, second order derivative u double x. Here you have to use quotient rule of differentiation. What is quotient rule of differentiation? U by v, vu dash minus uv dash divided by v square. So v is our denominator, numerator differentiation, x differentiation is 1, minus numerator, denominator differentiation, x square plus y square differentiation is 2x, divided by denominator square, v square. Now u double x value is x square plus y square, so y square, x square minus 2 times of x square is minus x square, divided by x square plus y square whole square. Here similarly now we have to make the differentiation with respect to y. Uy, first 1 by 2 log differentiation is 1 by x square plus y square. X square plus y square differentiation is 2y because we are differentiating with respect to y here. Uy equals, here this 2 and 2 get cancelled, y divided by x square plus y, a square plus y square. Next derivative u double y. Here we have to use quotient rule of differentiation. X square plus y square, numerator differentiation is 1, minus y, denominator differentiation is 2y because y is the variable now. X square plus y square the whole square. So u double y value is x square, y square minus 2 times of y square is minus y square, divided by x square plus y square the whole square. Now adding these two terms, what will happen? U double x, u double y equals x square plus y square whole square, denominator same, you can add the numerator alone, y square minus x square minus y square, all the terms get cancelled on numerator, so it becomes 0. Now Laplace equation is verified for the function u, so which implies that u is harmonic. U is harmonic. Next we have to calculate the analytic function f of z. In step 2 I am going to find f of z. So f of z, what is the value of f of z? F of z equals phi 1 of z comma 0 dz minus I phi 2 of z comma 0 dz. Phi 1 is nothing but ux at z comma 0. Now what is our ux value? This is my ux value. X by x square plus y square is my ux value. X by x square plus y square is my ux value. Now substitute the point z comma 0. So z divided by y value 0. Z square 1 divided by z. Next phi 2 value. Phi 2 of z comma 0 is uy at z comma 0. uy value is y divided by x square plus y square. When you substitute z and 0 here, 0 by anything, it will become 0. Now my phi 1 value is 1 by z, phi 2 value is 0. So f of z equals 1 by z dz minus I, my phi 2 value is 0. So f of z equals 1 by z dz is log z plus integrating constant c. So this is my f of z. Now, and the third part is we have to calculate the conjugate. To find the conjugate, in this question we are given real part. So conjugate of real part is our imaginary part. That is to find v. So for finding value v, you consider this f of z. You consider this f of z equals, you consider this f of z without constant. So f of z equals log z. F of z equals, I am going to calculate the imaginary part, that is v, log, I am taking z in polar form. The value of z in polar form is r e power I theta. Now log r plus log e power I theta. Log r plus log and e, a logarithmic term and exponential term get cancelled, I into theta. So now we have to calculate theta. How can we calculate theta? If z equals x plus iy, r is its magnitude value, real part square plus imaginary part square. This is my r value, and theta value is tan inverse of y divided by x. Theta value is tan inverse of y divided by x. So now f of z equals log r plus I into theta value is tan inverse of y by x. So f of z is u plus iv, u plus iy, iv log r plus I into tan inverse of y by x. So but here in polar form, here in coordinate, that is Cartesian form. So what is log r? What is our real part? Real part is available in our question itself, because in the question we are having our real part. What is my real part in the question? Half log of x square plus y square. So it is very simple. R value is square root of x square plus y square. This is my question. I tan inverse of y by x. So half, this is power half. We can write it as half log of x square plus y square plus I tan inverse of y by x. So when you are equating, this is my u, which is available in our question itself. But we have to find the conjugate. So this is the conjugate. V value is tan inverse of y divided by x. That's all. Next question. Find the analytic function. Find the analytic function whose real part is e power x cos y minus y sin y. Now, real part. Clearly they have mentioned it is real part. U equals e power x cos y minus y sin y. So we have to find the analytic function only. That is just differentiate. That is it is essential to find phi 1 and phi 2 value. Differentiate with respect to x. E power x. Here 1x and here also 1x. So we need to use product form of differentiation. U v dash plus v u dash. So ux. I am taking this as my u term and this is v term. E power x v dash. V dash means x cos y. X differentiation is 1. I will do it again. Wait. Or else I will use eraser. Now I will consider it as u. U and this is v. U equals e power x. V equals, I will take some other notation. V equals x cos y or x cos y minus y sin y. U dash e power x. V dash x differentiation is 1 cos y, the rest of the terms will become 0. So the formula product rule of differentiation is u v dash plus v u dash. Now ux is e power x cos y plus x cos y minus y sin y into e power x. Now no need to simplify further, just substitute the points alone. So here e power is at cos 0 value 1 and here x is at cos 0 value 1 minus y is 0 0 e power z. Now e power z plus z e power z. E power z 1 plus z. This is my phi 1 of z comma 0 value. Next, for finding phi 2, we have to differentiate with respect to y. So again I will write u value x cos y minus y sin y. So u with respect to y, e power x constant, x cos y differentiation is minus sin y minus, here we are having two functions. So here again you have to use, because both the functions are in terms of y only. So we have to use product rule of differentiation again here. U v dash plus v u dash. So e power x minus x sin y minus u is y, sin y differentiation is cos y, plus v is sin y, y differentiation is 1. So now directly you can substitute your points. Z comma 0, e power z minus sin 0, here sin 0 is 0, here y is 0 means 0, and here sin 0 is 0. So all the terms 0, our phi 2 value is 0 only. Phi 2 value is 0. Now f of z equals integral phi 1 of z comma 0 dz minus I phi 2 of az comma 0 dz. So f of z equals phi 1 value is e power z into 1 plus z, e power z into 1 plus z dz minus phi 2 value is 0. So f of z is equal to, here you have to use product rule of integration by parts, uv minus u dash v1 plus etc. Now u is our algebraic term, u is 1 plus z, remaining term is dv e power z dz, u dash is 1, u double dash is 0, and here v is e power z, integration is e power z, v1 again e power z. The formula is uv minus u dash v1. Now substitute the terms in the formula, 1 plus z e power z minus e power z. F of z equals, if you are taking e power z is common term, 1 plus z minus 1. F of z is equal to e power z, 1 and 1 get cancelled, 1 and 1 get cancelled, so ez. F of z equals z e power z, and finally add the integrating constant c. This is my analytic function. F of z is equal to ez e power z. Next question. Question number 3. Find the regular function. Regular function is nothing but analytic function only. Find the regular function whose imaginary part is e power minus x x cos y plus y sin y, x cos y plus y sin y. So here v is given. So given that v equals e power minus x cos y plus y sin y. So for v, first if imaginary part is given, you should differentiate your v with respect to y, because phi 1 is from y only, vy only. Now differentiate with respect to y, e power x is constant, here x is constant, cos y differentiation is minus sin y, plus here we can use product rule, y cos y plus sin y into 1. Now simply you can substitute the points, e power minus z, sin y, sin 0 is 0, 0. Even though cos 0 value 1, because initially y is here, so again 0, sin 0 value 0. So our phi 1 of z comma 0 value is 0 only. Next, differentiate with respect to x. Let me again write the value of v x cos y plus y sin y, v x. So here we are having one x, here we are having one x. So again we have to use the product rule. So let me take it is p and q. So because same notations, it will be confusing. pq dash plus qp dash. So p is e power minus x, q is x cos y, y sin y. Now we are differentiating with respect to x, vx. So p dash e power minus x into minus 1, q dash x differentiation is 1, cos y, here 0 because there is no x term here. Now our vx value is e power pq dash e power minus x cos y plus qp dash e power minus x cos y, here one minus is there, so minus x cos y plus y sin y into e power minus x. Now substitute the value z and 0. E power minus z cos 0 is 1. And here is z cos 0 is 1. And here y 0. So e power minus z. E power minus z minus z e power minus z. So 1 minus z e power minus z is my phi 2 of z comma 0 value. Now substitute the terms in the formula f of z, or else integral f dash of z dz equals phi 1 of z comma 0 dz plus I phi 2 of z comma 0 dz. You can directly write this as. So phi 1 value is 0, I into my phi 2 value is 1 minus z e power minus z dz. So f of z is 1 minus z e power minus z dz. Now here we have to use integration by parts, so or else Bernoulli result u dv. U is 1 minus z, dv is e power minus z dz. U dash minus 1, u double dash 0. V is e power minus z divided by minus 1. V1 is e power minus z divided by again minus 1, the whole square. So e power minus z. The formula is uv minus u dash v1. F of z equals uv minus u dash v1, because from u double dash onwards it is 0. So f of z is 1 minus z e power minus z divided by minus 1 minus u double dash, and formula itself minus plus e power minus z. So e power minus z minus 1, because here one minus 1 is there, minus 1 plus z. If you move this minus here, minus 1 plus z plus 1. So e power minus z is z. And finally add the integrating constant c. So z e power minus z plus c. This is my analytic function b. Next one. One more question. If w equals u plus iv is an analytic function and v equals x square minus y square plus x by x square plus y square, find u. Find u, that is we have to find the conjugate. But if we have to find, that is we have to find u. For finding u itself we need the analytic function f of z. So again we have to use Milne-Thomson method. So here imaginary part is given, that is to find f of z. First we should find f of z, then only we can get u value, that is conjugate value. Here v is given, so automatically v should be differentiated with respect to y first. So x square value is, differentiation is 0, minus y square is 2y, plus here we have to use quotient rule of differentiation, numerator numerator differentiation with respect to y is 0. 0 minus u numerator, denominator differentiation is 2 times of y divided by x square plus y square, the whole square. Now substitute the point. Before that, let me simplify further, and here minus 2xy divided by x square plus y square. If I substitute z comma 0 here, what will happen? Here 0 and here 0, so entire term is 0. So vy, when you substitute the point z comma 0, it will become phi 1. Phi 1 of z comma 0. Next, p should be differentiated with respect to x. Let me write p value again, x by x square plus y square. So v with respect to x, x square differentiation 2x, y differentiation 0. Here quotient rule. Denominator plus differentiation of numerator. Differentiation of numerator is 1 minus numerator differentiation of denominator with respect to x. So 2 times of x divided by x square plus y square whole square. And vx equals 2 times of x plus here y square, x square minus 2 times of x square, so minus x square divided by x square plus y square whole square. Now substitute the point z and 0. 2 times of z plus minus 2 times of, here 2z minus z square, z square plus 0, z square the whole square. So 2z minus z square get cancelled, minus 1 by z square. 2z minus 1 by z square, we can take it as z power, move this z square on numerator, z power minus 2. This is my phi 2 value. So our formula is phi 1 of z comma 0 dz plus I phi 2 of z comma 0 dz equals 0 plus I phi 2 value is 2z minus z power minus 2 dz. So just integrate this, 2z square by 2 minus z power minus 1 by minus 1. I z square minus 1 by z plus c. This is my f of z. Now we have to calculate the conjugate, that is u, to find u. So for finding u, consider the same function without c. So f of z is equal to I z square minus 1 by z. Now replace all the values. Z value is x plus iy. Z square means what will happen? X plus iy the whole square. Because I have to substitute the values here. Z value, Z square value. The x plus iy whole square. So x square, I square, y square plus 2x iy. I square value is minus 1. X square, y square plus 2x iy. This is my z square value. This is my z square value. And what will happen? 1 by z. 1 divided by x plus iy. So in complex numbers, denominator, it should not contain complex variable. That is x plus iy. So in that case, we need to do the process like multiply and divided by the conjugate. Conjugate of x plus iy is x minus iy. So x minus iy, here x plus iy into x minus iy. So x minus iy divided by a square plus b square. So a square minus b square, but in complex numbers it will become plus because I square value is minus 1. So x minus iy divided by x square, I square value is minus 1, it will become plus x square plus y square. This is my 1 by z value. 1 by z value is x minus iy by x square plus y square. Now substitute all the values in f of z. So what is our f of z? Here you have to substitute all the terms. Put z square 1 by z in f of z. So f of z is I x square plus y square square, z square value is x square minus y square plus 2 times of ixy and plus 1 by z value is x minus iy divided by x square plus y square. Now simplify the terms. I x square minus y square plus 2yxy plus x by x square plus y square minus iy by x square plus y square. Now separate the terms as real part and imaginary part. So what is my real part? This one, x square minus y square, and this one plus x by x square plus y square. What is my imaginary part? 2 times of xy minus y by x square plus y square. Now multiply this I along with this expression. So I x square y square plus x by x square plus y square plus I square 2xy minus y by x square plus y square. So I square value is minus 1. So I x square minus y square x by x square plus y square minus I square value is minus 1. So I will move this minus 1 within this bracket. It will become, this is positive and this is negative. Y by x square plus y square minus 2 times of xy. So now this is my real part and this is my imaginary part. So u plus iv is f of z. This is our f of z. So u plus iv is y by x square plus y square minus 2 times of xy plus I x